I'm fine with you using notes on it. But the thing is, it's going to be all multiple choice as well, but it's probably going to be like 40-ish questions. And so if you're spending time looking through your notes on every single question, you're going to run short on time. So, but I don't mind letting you use notes on that too. All right, so factoring polynomials. So whenever you're asked to factor something, your first thought should be, or your first instinct, first strategy, look for a greatest common factor. Because if you can factor out a greatest common factor, that will make things easier. And this greatest common factor is not just with quadratics, it's with any factoring one. All right, so this one, 6x squared y cubed 9x y to the fourth plus 18y to the fifth. So look at the numbers first. What's the biggest number that we could factor out? Okay, I can factor a 3 out. Can I factor an x or multiple x's out? No, because it's not in all three terms. X squared means I have 2 x's in the first term, 1 x in the second term, and no x's in the third term. So I cannot factor out an x. But I can factor out y. How many y's, Dayton? 3. So my greatest common factor would be 3y cubed. So this becomes 2x squared, and then 3xy plus 6y squared. And that's as far as we can go. All right, we're not going to do any more factoring beyond that. All right, this is simply pulling out that greatest common factor. Okay, let's look at B. All right, so what is the greatest common factor in B? So first I'll look at the numbers. Is there a common number that I could pull out? 7. Oops. Okay. Is there anything else that I can take out? Yeah, I can bring this entire m plus 1 out because the first term's got, why is it not showing up? It's because it's going to drop here in a second. Okay. There. There we go. All right, so the first term has 3 m plus 1s, the second one has 2 m plus 1s, the third one has 1 m plus 1. So we can factor out an m plus 1. And then I'm going to do brackets just to separate these so we know, okay, I've factored this out. You can do a big parenthesis if you want, but I want to explicitly show, okay, this is factored out. So then I'm going to have 2 times m plus 1 squared minus 4 times m plus 1. And then this one would just be minus 1 here at the end. So after I factored out what I have in my brackets is what I still have left. All right, let's do a little simplifying. So m plus 1 squared. Well, we know that's m plus 1 times m plus 1. So that ends up being m squared plus m plus m plus 1. So m squared plus 2m plus 1. So let's fill that in here. So I still have my 7, m plus 1. But now I have 2 times m squared plus 2m plus 1. And I'm going to just go ahead and distribute this in. So this will be minus 4m minus 4 minus 1. All right, let's continue to simplify this. So 7 times m plus 1. In my brackets here, I'd have 2m squared plus 4m plus 2 minus 4m minus 4 minus 1. All I'm doing is expanding through all my terms. Well, I can see I have a positive 4m and a negative 4m. So those ones go away. I don't have to worry about that. So that's the only thing that will go away. So 7 times m plus 1. Let's use a bracket still. 2m squared. And then all I have is some constants. 2 minus 4 minus 1. So 2 minus 4 would be a negative 2 minus 1 would bring me to a negative 3. This is fully factored in this problem. But first we had to bring out that greatest common factor, which was 7 times m plus 1. Okay. Factor by grouping. When a polynomial has more than 3 terms, it can sometimes be factored by grouping. So not every time. And there is a connection from here. It's kind of like 4 spots. So if you had Miss Johnson, she talked about factoring with 4 spots. We're kind of already in that step now where we've done 4 spots. So if I were to group the first 2 and the second 2. So the first one I could factor out an a, so it'd be x plus y. This other one has to be x plus y, and so I would factor out a 6. And when I say sometimes you can do it, these have to be the same. The x plus y, that has to be the same. If this had been 6xy plus 6y or something like that, it wouldn't have been able to work. All right, so it's going to work as long as we can get a common factor on each term. In this case, it's x plus y. So then I have a plus 6 times x plus y is factored form. So it's factored by grouping. Simply create your groups because you got 4 terms going on. Factor each one. It's like it's already in 4 spot for you. Find a greatest common factor of each and go. All right. If we did factor by grouping here, so if I want to work with this step, there's nothing that I can factor out. 2y squared plus az, I can't do anything. There's nothing I could factor out of this. But with polynomials, I can move stuff around. So I'm going to change this up. I'm going to say this is 2y squared minus 2z plus az minus ay squared. Now let's look at doing our groupings, because now I can see, all right, I do have this in a better spot. I can factor out a 2. So this would be y squared minus z. But on this one, I have, if I factor out a, I have z minus y squared. That's not the same. Okay, y squared minus z is not the same as z minus y squared. This would have been a positive a. Well, if I change this up, if I change this to a negative a, then it becomes a negative z plus y squared. Now it does match, because I could write this one as negative z plus y squared. That's still the same with that constant multiple of 2. So now I can write it as 2 minus a times negative z plus y squared. So we can do some manipulating around to make our 4-spot method with grouping work. If it's just the signs that are different, we can work with that. All right, so greatest common factor, that should be your first thing to look at every single time. Can I factor out a greatest common factor? That's one strategy. Factor by grouping, this is another strategy. It has to be 4 terms to start out with. And when you're doing your grouping, you have to have a common multiple. So this one was negative z plus y squared, and this one was x plus y. That has to be a common multiple of each set of groupings that you do. They have to be the same. All right, factoring trinomials. So this is 4 spots. And if you had me for algebra 2 or even algebra 1, we talked about doing the cross method. Where the cross, again, it's a times c on the top, and they will sum to our b value on the bottom. So I'd have 24 on top that will sum to be negative 11. All right, I know I could have a negative 8 and a negative 3 would work. But because of this 4 here, I need to write this with 4 spots. I'm not factored yet. I need to do it into 4 spot. So this would be 4y squared minus 8y minus 3y plus 6. This negative 11y got split up to be a negative 8y and a negative 3y. Now we can do our groupings. And I'm going to separate these groupings with addition, so that negative is going to go right with that 3. Factor out, I could factor out 4y from this one. And so that would be y minus 2. This is going to be y minus 2. So this had to be a negative 3. So my common factor is y minus 2. The other one is 4y minus 3. So this is factoring when your a is not 1. We need to go into that 4-spot method. All right, let's do another one with that 4 spots. So we have 16 y cubed plus 24 y squared minus 16y. So that cross only works for quadratics. This is a cubic. But again, the first thing we should look for on any factoring problem, is there a GCF that I can bring out that'll make things a little bit easier? So this one, there is a GCF. I could bring out 8y. And so now this becomes 2y squared minus 3. It'll come back. Maybe. I don't know why it drops. I'm hardwired in. There it is. Now it's not showing up on my screen. All right, so minus 3y minus 2. So now I do have a quadratic here in parentheses that I can factor. So now I can use my cross method. So it'd be a negative 4 that adds up to be a negative 3. Well, that would be 4 and negative 1. Maddie? Yes, thank you. So this should be, there we go. Yep. Thanks. Glad you caught that. So this 8y continues to come along. I'm going to do brackets just to emphasize that we got a whole new grouping that we're working with here. 2y squared plus 4y minus 1y minus 2. to my groupings within this. So I could factor out here in my brackets, I could factor out 2y, and so this would be y plus 2. This one I want to be y plus 2, so that means I could factor out a negative 1. 8y is still up front here. So now final answer, I'd have 8y times 2y minus 1, y plus 2. So when you factor out that greatest common factor, don't throw it away. It's still there. It's still a part of the problem. It just carries along throughout the problem with us. Okay, now factoring binomials specifically. Difference of squares. Does anybody remember what difference of squares, what's this factors to be? So I have a squared minus b squared. What does that factor into? Ben, what you got? A minus b? Good. Okay, so with difference of squares, if I have something squared, okay, so say we had like 2 squared minus 3 squared. Okay, well, I'll back this up. Let's say it was 4, we'll just say 4x squared minus 9 or something like that. Okay, that's really 2x quantity squared minus 3 squared. So when I do my difference of squares, I'd have 2x plus 3, 2x minus 3. So recognizing your base, your a would be your base, what squared, that becomes your a and that becomes your b. Now, difference of cubes. Can anybody tell me the formula for difference of cubes? I'll automatically give you 25 extra credit points on the exam if you can tell me difference of cubes from memory. Okay. All right. So this one, difference of cubes, becomes a minus b times a squared plus 2ab plus b squared. All right, and this is not one that we use often, so I don't expect you to have this one memorized, but write it in your notes so that you have it. A cubed plus b cubed would be a plus b, a squared minus 2ab. Back this up. It shouldn't be 2ab, it should just be ab. I even got it wrong. Plus b squared. Let me check that in a minute. I feel like that's not right. All right, so again, it was just AB, not 2AB. I had to check myself on that. A squared plus AB plus B squared. An acronym to remember the signs on this, you could think of SOAP. And I'll write it out this way. So in terms of the signs, it's the same, it's the opposite, always positive. So if it's a negative, and so subtraction, this is what it means by the same. The opposite, because now it's addition rather than subtraction. And then the last one is always positive. Okay, so it's always a squared, ab, and b squared. Only thing that's different is the signs. And if you remember that acronym of SOAP, that'll help you keep the signs straight for each one. All right, so let's use this. Let's actually factor. So 4g squared minus 9, this is like the one that I actually just did. 4g squared, I could write that as 2g quantity squared minus 3 squared. So I know my difference of squares is a plus b, a minus b. And so this becomes 2g plus 3, and then 2g minus 3, and I'm done. This is a quadratic, a degree 2 polynomial. You could still do your cross, and you could still get to the same answer. But difference of squares, if you can use it and remember it, it just creates a little efficiency, lets you go through it faster. One way is not correct over the other way. Either one works. But now a difference of cubes, because this is really x cubed. What can I cube to get 64? What cubed is 64? 4. So this is really 4y cubed. It's going to drop again. Just doesn't want me to use it today. Try. I do these to help you guys, though. So when you get to the problems, you have an idea what to do. I just got this and one more example, then we'll be off. You'll be off and rolling. Okay? All right. So this is same, opposite, always positive. So same would be x minus 4y. X squared, opposite would be plus, and this would be 4y times x, so 4xy, and then always positive, 4y quantity squared. And I'd like to see you simplify that last one to be x squared plus 4xy plus 16y squared. So using difference of cubes, this would be factored form. Okay. All right. Let's take a look at this one and then we'll be done. If we were to factor this, 6t to the fourth minus 13t squared minus 5. So this is factoring by substitution. So I have a degree 4 polynomial. So degree 4, it's not a quadratic. I can't do my cross or anything. I would look to see if there's a greatest common factor. There's not a greatest common factor. It's not a difference of cubes. It's not a difference of squares. Another option I have is using substitution. I'm going to say that I'm going to use a to represent t squared. So anywhere I have a t squared, I'm going to call that a. So now this becomes 6 times a squared, because a squared squared is going to be the same, or well, a squared, yeah, a squared squared would be a to the fourth, so that's where I want to get right back to. So instead of saying 6t to the fourth, well, t squared is really a, so I could say 6a squared. Same thing. And then minus 13a minus 5. So I've taken a quartic, a degree 4, and changed it into a quadratic with this substitution. I'm going to say, okay, anytime I have a t squared, I'm going to replace that with a. Now this is the form of a quadratic, and so I can say, okay, two numbers multiply to get 30, or negative 30, that add up to be a negative 13. All right, well, I know I could do 10 and 3, or 10 and 2. No, 10 and 3 won't work because I can't get a negative, because if I did negative 10, negative 3, that would give me a positive 30, so that's not going to work. But I could do negative 15 and a positive 2. That would give me a negative 30. Combine those together, I end up with negative 13. All right, so I have 6a squared minus 15a plus 2a minus 5. Do the factor by grouping. I could factor out a 3a, so this would be 2a, and then minus 5. Conveniently already have 2a minus 5, so really all I had to factor out would be a 1. So 2a minus 5 is my common factor, and then 3a plus 1 would be the other one. But we are not done because a is really t squared. So this becomes 2 times t squared minus 5. And then this one becomes 3t squared plus 1. That would be fully factored now because it's back factored in terms of t. That a was arbitrary. I introduced that a. That wasn't initially in the problem. So I need to put it back to what a really represented. Okay. All right. This one we won't work through completely. But you could look with one that looks like this. I could also, using substitution, I could say, well, a is 2x minus 1. And so now this becomes 10a squared minus 19a minus 15. And I can go through my work. And then at the very end, I'm going to replace a back with 2x minus 1. So we could have it where what we're substituting in, it doesn't have to be a quartic polynomial, but using the substitution makes things easier for us. Okay. All right. You don't have to worry about all those. So our point 4 is actually in Math Excel. Work on those. Have those ready to go for tomorrow. I will not be here tomorrow, so I'll have a video and notes for R5 for you to work on. So work on those, and then I'll be back on Monday, or I'm back on Friday.